Now we're going to talk about queen management, requeening, and queen acceptance. There's a lot to queens that people don't understand, and we're going to dive into some research, and I'm going to be quoting some other people. And anytime I'm quoting somebody else, I will recognize it at the bottom of the slide. And if there's no recognition, that's just my thoughts. I tend to use the slides as bullet points to remind me of what to say so I don't forget some important point that I wanted to make sure I said. So there's a little of that going on here too. And we'll just get right into it. Backed by a lifetime's experience, I am firmly convinced that whatever the method of introduction employed, the factor which determines acceptance or rejection in introduction is primarily the behavior of the queen in every case. Brother Adam, from his book Beekeeping at Buckfast Abbey. Has anybody in this room heard of this man? Now, when I do this in America, people are puzzled. They're a little puzzled. What is he talking about? I figured I'd come over here and you all know exactly who this. I quote him a lot from this book. This is a brilliant book. If you haven't read it, I highly recommend it. You won't learn a lot about varroa mites and things like that, but you'll learn some really good beekeeping husbandry. He was a brilliant man, in my opinion. Started working in the apiaries at Buckfast Abbey in 1916, and I don't know what year he passed, but I think it was sometime in the 1980s. And this book is a very good book. He's written several books. He was from Germany originally, a very smart fellow. And I'm going to quote him at least once, maybe twice in this presentation. Now, 1975, that's before much of the modern research that we have today, so keep that in mind. This was his experience. Brother Adam was brilliant because what he knew came from experience. He had the wisdom that came with experience. It just wasn't entirely research and book reading like a lot of folks today. And here's a slide that begins to tell the story. It's very busy, and I'll explain it as we go through it. This is a research study done in Australia. So if you look at the dates in the left column, the dates are upside down to us, they're below the equator. And what it's talking about is introduction, survival success, and then success in some weeks later, and we'll go through all the data together. 1999, 2000, 2001, each year, of course, is a little different, but the trend is the same in every case. If we go to the second line, age of queen when caught, meaning they put in a right queen cell that was ready to hatch, came back 7 days later, caught that queen, put her in a cage, much like the cages that we use to introduce a queen into a colony or a nuke, or to requeen a colony or whatever. And in that case, it was a mating nuke, a queen mating nuke, and the 7 stands for days. In other words, that queen was 7 days old when it was harvested and then reintroduced into another colony. And as you go across the top line and you see the introduction survival success, it's only 15.4%. Then all the way to the right, the early survival success, in other words, how many were actually accepted and continued on, it was only 10.3. This makes a pretty good sense because this is a queen that hasn't been laying any eggs yet. There's a really, really good chance that she's not even mated yet. So you go to the next line, which is 14 days out of a queen mating nuke, and you can see how the numbers jumped. Over to introduction survival success, 47.5, and then early survival success was really poor over to the right. Of course, if you go down, the other years are different. Looks like 1999 was a really bad year for queens, but we're just looking at the trend. Now look what happens if you wait till the queen is 3 weeks old. Look at how the numbers jump dramatically. And in the other years, it does the same thing. Somebody told me that some of the queen producers in this area will wait 14 days after a cell is introduced to harvest the queen and then reintroduce her into another colony. In other words, harvest the queen, sell her to somebody else that's going to use her. In our country, it's very common for large queen producers to harvest the queens on a 14-day cycle. The queen is mated as long as the weather was good. That's a big if. And if the weather was good, she's been laying for a day or 2 or 3. And as soon as they see eggs, she's in a cage, she gets sold, and off she goes. Well, that's highly problematic, and I would submit that they're doing the beekeeping public a great disservice by doing that. If they would just wait 1 more week, look at the difference in the numbers. And when I'm in America, I like to ask for a raise of hands and say, who in this room would be willing to pay an extra $5 for a queen that had been allowed to be in the queen mating nuke for one more week? And after looking at this data, of course, everybody raises their hand. And in 28 days, same, pretty good. That sweet spot is in between 21 and 28 days. Now, as a commercial queen producer, at some point, you can't just wait forever because you're losing money. That queen mating nuke is an asset that's supposed to be generating you income, so you can't wait forever. And I think the sweet spot, in my opinion, between quality of the queen harvested and the money that you're making or losing if you wait longer is right around 24 days. And that queen deserves to be a little more expensive because you've actually invested more in her in time in the queen mating nuke. So the number in the left-hand corner where it says 24B, that is queen bank. There's also an effect when you bank queens. In our country, queen producers would bank them so they get a big enough number perhaps to fill an order. It's not good either. You don't want to bank your queens more than a few days if you can help it, because that also has an effect on the queen quality. This is number of queen bees present at 15 weeks after introduction. You can see the same trend. The numbers are still, going up for the first couple of weeks. Same thing. This is the pheromone profile. You can see the sweet spot for pheromone production seems to be between 28 and 28 days, where the queen really seems to be ripe for picking right there. And this is the study. If you're interested in looking at it, you can find it online, and there's a lot more information than just the 3 slides I just gave you. Reasons to requeen: poor performance, genetics, which in other words traits, better overwintering, large colonies for splitting, large colonies for pollination, less overall failures. And we're going to go through them one by one. Poor performance. I think everybody would agree that's what good performance looks like. That's a typical textbook frame of brood and pollen and open nectar or honey around the brood. So that's a pretty good pattern in my view. I'd take that every day. So, what are possible reasons for poor brood patterns? There's poor nutrition, in other words malnutrition, mites and viruses, imbalance between brood and nurse bees, poor mating, and toxic contamination. And we will pick on those one by one. This is what good nutrition looks like. Multicolor pollen in the comb. Not only multicolor pollen, but multicolor fresh pollen. Recent research has showed that keeping pollen in a comb over from the previous year is really kind of a mistake. The quality's gone down so far that they've proven that trying to raise queens off of pollen harvested from the previous year and kept perhaps in a refrigerator or freezer or however really doesn't hardly produce a very good queen at all. The poor nutrition really shows up in the quality of the queen. You have to be using previous or current year pollen. And of course, in my view, you wouldn't want to be raising or grafting queens until pollen's coming in anyway, because you'd be doing it too early. So once pollen comes in and you've got fresh pollen from this current year, that's the time to start rearing queens perhaps. Multicolored pollen, that's a sign of good nutrition. That's a sign of good nutrition. I know this is a small picture in the back of the room. I hope you can see some of these cells with larvae in them have copious amounts of brood food in the bottom of the cell. Royal jelly and brood food are not synonymous. All larvae are fed royal jelly up to the age of nearly 48 hours, and then beyond that, the queens continue to get royal jelly, and the open worker brood continues to get fed something that's similar but different, and we call that brood food. The chemistry is different, the nutrient profile is a little bit different, but if you see many times in the late winter, early spring, you'll see bees really making an effort to rear brood, and you'll see frames of brood like this, but the bottom of the cells look dry, you don't see those puddles. That's a sign of malnutrition. And if it's bad enough, it can also show up as not the greatest pattern in the world. So right now we're talking about what may make a pattern not look like the one we saw in the previous slide. Malnutrition can be a reason. Mites and viruses, of course. If you have a heavy mite load and they vector viruses into the colony of bees, of course you're going to have a bad pattern when it gets really bad. A really heavy mite load and the viruses take over, that can lead you to believe that you have a very poor queen when in fact it's just something else. It's viruses and mites and so on. Packages, I know you don't use them a lot here, but they're a really good example of an imbalance in the age of bees. When you harvest a package of bees and you shake bees out of a colony into this package to make a unit that you're going to sell, there are several ways of doing it. If you shake in a lot of old bees, like perhaps you shake really early in the morning before the field force is flying and you shake high up in the nest rather than down in the brood nest, you could be putting an imbalance of old bees in comparison to young bees in this package. That imbalance of, now any bee, even old field force bees can revert back to nurse bees, but they're not ideal. They don't do as good a job as they would have when they were young and actively working as a nurse bee. So if you get that situation going on where you've got a lot of old bees trying to grow a colony, it can also show up as a poor pattern. So in America, quality package producers will do two things. Either they'll wait for the bees to be flying in the field before they shake bees out of the nest into a package to ensure that they're getting mostly young bees, or they will shake through a queen excluder. If you take frames of bees and shake it into a box or a funnel with a queen excluder and just wait a minute, all the older bees will fly off and only the younger bees are slipping down through the excluder, and that's another way of getting young bees into your package. And they're just like any industry, any culture, there's really good, honest people that are trying to do the very best they can, and there's other people that just don't care. It's all about the bottom line or it's all about money. It's the same in the package producing industry, and it can show up as a poor pattern in your colony. Good mating. Polyandry is the word. It's huge. We'll spend a minute on polyandry. If you go to Wikipedia or Google or something like that and type in the word polyandry, you're highly likely to get a picture back with a Middle Eastern or a dark-skinned woman sitting in a chair with 3 or 4 men standing behind her. They're her husbands. Okay? Polyandry really means the female of a species mating and having the offspring of many males. And there's lots of animals on the planets that can do it. And forgive me if this is a little too colorful, but it's true. The human race can do it too. Okay? I'm not going to go down that rabbit hole. But this is important. And queen producers in the southern United States are often guilty of producing queens too early when either the weather can be questionable or there may not be a lot of drones in the air. I say you need, I get quite dramatic when I talk about drones. I say you need zillions of drones in the air when it's mating season, not just a handful. It's very important that the queen mate with multiple drones because, well, right now I'm going to compare a colony of bees to a human being. We are a superorganism. We are full of cells that talk to each other, communicate with each other. All of this variety of cells, they all have different jobs. You know, some are cancer-killing cells. I mean, I'm talking out of my field here, but I think everybody understands that our body is full of cells that do different things. Well, the colony is a superorganism too. Look at the colony, not the individual bee, as a superorganism just like we are. They need a diversity of traits. And one drone that the queen mates with might come from a line of bees that's very good at collecting honey. Maybe the other one is very good at house cleaning. Maybe one drone comes from a line that is very hygienic, and they're showing now that a high degree of hygienic behavior can be one avenue toward mite suppression or mite resistance. It's also very important for things like European foul brood, American foul brood, chalk brood. Many issues tend to go away in a colony that is very hygienic. It's an important trait. Maybe some are good at defense or pollen production. The list goes on and on and on. So just like human beings in this room, every one of us has different skills, different traits. Imagine if we were all absolutely 100% identical. there's a lot of stuff that wouldn't get done because maybe somebody's a good carpenter. What would we do with a room full of carpenters and nobody's a plumber, okay? We need this diversity of traits, and so does a colony of bees. And in books you will often read that once you start to see drone pupa at the purple eye stage of growth, that on that day you can also graft your queen cells because both the virgin queen and the drone will be mature enough to mate at the same time. And that's very true. But I like to say that you have to wait till you see hatching drones because now that ensures that you have more drones in the air. If you start off with the very first production of drones, I don't think you have enough drones yet. I think you need to wait until you have a super abundance of drones out there for the queen to mate with. Not only so she has better odds of a high genetic makeup with what she's mating with, but also that she has to make less trips out of the colony to get mated, and then that decreases her the percent of the chance that she could be caught by a predator. So if you have a lot of drones in the air, you're going to have not only better mating, but you're going to have a more successful mating. In other words, the queens that actually make it back and are good enough to harvest and sell or use, you'll have a higher percentage if you have a lot of drones in the air. In my yards, we do it by wherever we have queen mating nukes surrounding that yard with other yards within 1 mile to 2 miles that are saturated with drone brood. And so we're surrounding our queen mating yards with drones from other colonies. So lots and lots and lots of drones, that's my opinion. Also, this is a good chance. I just used the phrase my opinion. I've used that about 3 or 4 times now. I always like to say, and I forgot to do it at the beginning of this presentation, I don't consider myself the final word on anything, okay? I'm not a researcher, I'm not a chemist, I'm not a scientist, I'm a beekeeper, and a lot of what I know came from casual experience and reading books from people, smart people like Brother Adam. So I think every experienced beekeeper in the room will tell you that the most successful beekeepers don't always go by just one thing that they're being told, but they glean all the information they can from a lot of sources, and they put it together and they come up with their way, okay? What works for me, even if you live right next door to me, what works best for me may not be the best for you because our minds work different. The way we handle things comes different. You know, our level of wisdom is different. So just know that I'm telling you all of this stuff, I'm giving you my opinion, but it's not the end word, okay? For all of you, if that makes sense. When experiencing premature queen failure and poor queen performance, chronically sick brood, or excessive and repeated colony losses, consider the age of your comb, what has it been exposed to, and what are the bees being exposed to now. Several of the slides in this presentation are really meant for American beekeepers. I learned with delight that in Scotland that you folks tend to cycle your comb out at a fairly young age. In America, many beekeepers are guilty of keeping their comb too long, and the comb gets contaminated with toxins. You don't even have to be doing anything wrong and it will become contaminated with toxins. I did learn also that, to my dismay, that in this country apistan is being used often. That the active ingredient in apistan is fluvalinate. It's highly problematic because it is readily absorbed by beeswax comb. It does not go away, and it just kind of stays in the colony. And and I'm going to show some slides with information about this. I know this isn't queen management per se, but it's something I try to put into every talk because I think it's such an important topic that's not being talked about, and that is how toxic synergistic interaction between chemicals that the bees are exposed to in the field and the chemicals that we put in the colony as beekeepers is just not being talked about enough, and it may be the most important topic on our plate right now. So we're going to dive into it a little bit because I will say that it can affect queen performance. So that's my little rationalization or excuse for throwing this subject matter in here. What goes on, let's see what the next slide is informative. Many of the toxins in nectar migrate to the comb because they are attracted to beeswax rather than honey. This is due to their lipophilic properties, which means that rather than dissolving in water, they tend to combine with or dissolve in lipids and fats, which is what beeswax is. Let's go back to this chemical fluvalinate that's in apistan. It's super absorbed by beeswax, and it just does not go away. You can shift out some of the combs in your colony and put fresh ones in, and it migrates from wax to wax. I have a friend that helps run the bee lab at the University of Georgia by the name of Jennifer Berry. Some of you may have heard of her. She's had a lot of research papers out. And she needed some pristinely clean wax to do a research project. And she took wax samples from across North America, and all of them were contaminated with coumaphos and fluvalinate. And then she gave up on North America, and she went to South America, and all of the beeswax samples down there were contaminated with DDT. Does everybody know what DDT is? Yeah. Bad stuff. She could not find any wax that was pristinely clean. In her opinion, it doesn't exist anywhere on the planet, and I might be tempted to agree with her. Not only was it coming from comb from beekeepers that had started with foundation, it was also coming from beekeepers that had never used these products, never been exposed to it, and even allowed the bees to make their comb from scratch with no commercially produced foundation. The chemicals they're just there. And what happens when we use these chemicals is we permeate our comb with them, and then if the bees go out and visit somebody's garden where there's some sort of synthetic chemical and bring it back home, something like fluvalinate, which in a research lab shows to be fairly gentle on bees, can actually have a synergistic reaction with another chemical and turn into something that seems to almost want to glow in the dark. And it's beyond our knowledge. In fact, I think, yes, let's go to the next slide. The number of toxic synergistic interactions that can be generated when compounds present in the comb interconnect with those being brought in by the bees is astronomical and virtually impossible to know. Now, we're not just necessarily talking about 2 chemicals. What about if there's 3 or 4 or 6 or 10? Think about the possibilities here. Now, to help people understand a little bit more about what I'm talking about, it can also happen in human beings with medicines. You know, maybe one medicine is good for blood pressure, another medicine is good for a skin rash, or just, there's all kinds of medicines, right? What happens if you're starting to take a lot of medicines? I'm going to tell you a little story that will drive my point home. I had a son of a friend whose mother-in-law was very sick and was put on hospice and was only given a week or 2 to live. And she got to the point where she needed some of her prescriptions filled. She was taking a lot of medicines. And they went to her medicine cabinet and figured out that she was taking over a dozen medicines for different things. And they thought, and I can kind of relate with this. It seems kind of rude, but they thought, she's just going to die in a week or 2. Why would we go out and get all this new medicine to give her? So they quit giving her any medicine at all. Guess what happened? She lived 3 more years because all of these medicines were not interacting well together. The same thing can happen with chemicals in our beehive, and we don't even know it. The word is insidious. The description of insidious is a on-scene, I'm paraphrasing the dictionary. It's an on-scene situation that we don't perceive with the eye, but is actually gravely sickening. An example would be an insidious disease that you don't know it's happening, but it's there and suddenly you're dying. And that's what can be happening in our colonies. So I'm so glad to hear that you swap your comb out often, but just know that you can have problems in your colonies that can be related to chemicals and you're completely unaware, especially if you're around areas where there's a lot of agriculture going on. Not only can they possibly spray the crops, but even if your colonies are there when they're not spraying, they can still be absorbing this toxicity from the guttation water that comes from the soil that It's, plants use water to pull up nutrients, and then in the morning they have to exude this moisture, and quite often it'll be added to or look like morning dew on the grass in the mornings. So even morning dew can be toxic if you're in an agricultural area. The word is guttation, if you're interested in that topic. And toxicity is all around us. It's in this room, it's on the table, it's on the microphone. It's just a part of life these days. Now, that's the bad news, but the good news is that, it's always been that way to some extent. The honeybees are very sensitive to toxicity, more so than we are, but they are capable of metabolizing a certain amount of toxin, just like we are. We have a liver, and in a beehive, we often say that the beeswax comb is the liver of the colony because it's absorbing all this garbage. Of course, that comb has to go periodically. And again, I preach about this a lot to American beekeepers because many American beekeepers are guilty of holding on to their comb much too long. Now we're getting back to our subject matter. Chronic exposure to sublethal concentrations of pesticides and fungicides in comb and the toxic synergistic interactions that occur can shorten a honeybee's lifespan. It weakens the immune system, alters behavior, and decreases colony populations. It also decreases sperm viability in drones and reduces a queen's fecundity, in other words, the ability to reproduce in abundance. In other words, if you have comb that is toxic, it can look just like you have a bad queen. And it doesn't take long, especially with chemicals like fluvalinate. Okay, now we're out of the chemicals. When is a current year queen the best? When is a second year queen the best? How old is too old and reasons not to requeen? And I'll probably say some things that are surprising to some people. Again, it's just me and my opinion. I've been doing this for 45 years. When is a current queen the best? The main reason for having a queen from this current year is that she will head a colony that will be less likely to swarm. Every time you have a queen that's from the previous year, whether it's a late season or early season, there's a higher propensity towards swarming. And it really sort of comes down to age, because a fall queen from the previous year will be less likely to swarm than a queen in the spring from the previous year. If you want to really try to keep your swarming under control, requeening in the spring with a current year queen will give you your best odds. Now, and also a queen from this current year will also give you a better colony going into winter, and you'll have a better success rate of overwintering. The queen will lay a little better going into fall and start up earlier in the late winter. She's more vigorous. It's just a better situation. You'll have more success. Now, when is a second year queen the best? And this is actually taken right out of Brother Adam's book. At Buckfast Abbey, he would routinely raise queens late in the season, overwinter them in a nuke, and then use those late season queens to requeen his production colonies the following spring. And he said invariably those were his highest production colonies. You would think that a queen from this spring would give you the best brood nests and the best colony going into midsummer, but according to Brother Adam, a queen that was several months older would do you a better job. And I'm going to compare bees to human beings. You might have a very young man that's very vigorous and very active, but perhaps somebody that's a little more mature. I said man, any human, women too. When they get a little bit more maturity on them, they're able to just settle in and do a better job. It has to, way back to that very first quote from Brother Adam, queen behavior in every case when it comes to introduction. And he's also adding to it that maturity is what's bringing this advance in behavior. When you introduce a queen that's older, she's settled on the comb, she's not nervous on the comb, she goes down, she gets into business. The bees, if a queen comes out of a queen cage and gets released and she's very nervous because she's very young, the bees sense this immediately, and it can be part of the problem of her getting accepted. Here he's telling us now that if she's actually going to make more honey for you if she's an older queen. Where is the point? Now here's the but part of this. Where is the point of diminishing returns? At what point is that queen now becoming older and perhaps not as productive? And when people ask me, when do I think a queen needs to be replaced? We requeen every year whenever possible. You don't have to. People will argue with me and say, I've got a 2-year-old queen that is still doing a really good job. And of course, the answer is that many of them do, but the percentage of them doing a good job goes lower. And the percentage of them that will go into winter heading a very vigorous colony is lower. If she's doing a great job at 2 years old, what was she doing when she was 6 months old? Now, rather than use age as a determining factor on whether a queen is over the hill, so to speak, or not, I use the mileage. If a queen has been through 2 spring peak periods, we all know that, it's probably a little different here, but for us it's from early April into early June, there's this big spike in brood production. If she's been through 2 of those spring spike productions, she, in my opinion, is now over the hill. She'll no longer be as good as she ever was. And that can happen with a queen that's not very much older than a year old, or it can not happen with a queen that's almost 2 years old. Does that make sense? It's not the age, it's the mileage. What has she done? And Brother Adam also talked about this when he had very special breeder queens. He would keep them in small units because he knew that they'd last a lot longer if he constricted their brood rearing. And we do the same thing. All of our breeder queens that we want to hold on to, we keep them very small, just big enough to produce the larvae and stuff we need to for grafting. And much like a car, the more miles you put on it, you could have a car that's 2 years older than another one, but they're different because of the mileage, if that makes sense. Same thing with a queen. How old is too old? I guess I just said that. It's not necessarily in years, it has to do with what she's been through. Reasons not to requeen: if you want to hold on to those genetics, why would you replace her if what she's doing is so special to you that you want to use her as a breeder queen, or perhaps she needs to be drone stock in your mating yards. And also, if you want to breed for longevity, if you're replacing a queen every year, obviously you're never going to figure out what lines have genes for longevity. Strategies for replacing queens: replace only when needed, replace all queens each year, replace when splitting. Is it okay to use swarm and supersedure cells? Now, I just told you that I like to replace them every year, and there's more reasons than that what meets the eye there. I want to know that I have a good outfit going into winter. I don't have the time to keep a really close eye on every queen. If you're able to watch your queens very closely and know when that queen seems to be slipping just a little, that's a good time to requeen. And yeah, it could be a year and a half old or something like that. But so replace only when needed is a very legitimate approach. Replace all queens each year is my approach. On a larger scale, it's safer. I have higher levels of production when I average my outfit out as a whole. Replace when splitting: obviously, if you're making nukes or making packages and you had to find the queen, she's in your hand, why wouldn't you just, requeen right then? You've got her. Is it okay to use swarm and supersedure cells? Absolutely, yes. I think everybody in this room would say, supersedure cells and swarm cells make good queens, but it even goes farther. Recent research has showed that it's a better queen from the moment the egg is laid. When an egg gets laid in a queen cup, it's already 4% larger, it's richer, it's fatter, and it's already destined to be a better insect than the egg that was laid in a worker cell. Not only that, but it's fed copious amounts of royal jelly from day one. So with the feed, the nutrition is even different. And there's only one time when I would suggest not using swarm cells, and I learned this the hard way. It seems like much of what I know I learned the hard way. Way back when I first got going, I needed to grow fast and I didn't have any money, and I would use swarm cells a lot. And even if I found swarm cells early, there's always these outlier colonies that are trying to swarm 2 or 3 weeks before the rest are. Well, I'd use those swarm cells too. And guess what I had after 4 or 5 years? I had 500 colonies that all wanted to swarm early. I had been breeding unintentionally for the swarming impulse. You can actually do exactly the opposite. You could plug out your old apiary and to the point where they have to swarm, and if there's 1 or 2 that are not trying to swarm, you could breed from them and be breeding for exactly the opposite. So you can breed for swarming and non-swarming if you want, just like many other traits. Supersedure cells, same thing. When an egg is laid in a queen cup, it's already better than the egg that was laid in a worker cup. Other things that can affect acceptance, timing, obviously. I think many people in this room would recognize that during a nectar flow, you'll get much better queen acceptance. It's because the bees are preoccupied. I like to say hungry bees don't want to take a queen, and gorged bees are happy to take anything. So feeding, good and bad, weather, what we like, they like, field force, grouchy bees. You can actually, this nectar flow situation, you can actually emulate that with feeding, but you have to be so careful, because if it's a dearth and you cause robbing, your queen acceptance rate just went down the tubes. If you can gorge your bees out with them not robbing because of a little mess you made or any other reason, your acceptance will be much better. If robbing starts in your apiary, you can just bet on your queen acceptance rate going down fast. Robbing is problematic. Whether what we like, they like, anything that makes us uncomfortable makes them uncomfortable. If it's a rainy, cold day and we don't like it, they don't like it either. And just like a baby, they will be grouchy and take it out on you. Field force, grouchy bees, absolutely. It's not the older bees that want to accept a new queen. The young nurse bees that have never been out of the colony, they're the ones that are more inclined to take just about anything you give them. When you're getting stung up in the apiary, most of the stinging is occurring by older, grouchy, field forest type bees. It's the old bees that are more defensive. Young bees are not inclined to sting at all. So I'm going to tell you a little story. I'm going to move along quickly. I do see a few people kind of rubbing their eyes. I don't mean to go too long here. You can give me the hook anytime you want. So I had a friend in Oregon that did something that sounds alarming, but I'm just telling you the story, not to tell you to do it, but to kind of share the principle behind the situation. He liked to requeen his colonies in late summer, so he'd have the very best colonies going into winter, because when you take colonies down to California for almonds, you would get premium price for very premium colonies, and he wanted to guarantee that. And August is a dearth period in that region, very hard to requeen entire apiary, because his yards were 64 colonies, because that's what would fit on a truck. And a couple of beekeepers going through 64 colonies looking for queens during the dearth is almost guaranteed to go crazy with robbing before you're finished. And then first of all, finding the queens is hard. You're getting stung up. And then also getting a queen acceptance is really difficult. He actually did something that sounds absolutely insane. In the middle of the day, he would pick up that entire yard of bees, and except for one pallet he would leave behind. He would move them 1/2 mile to 1 mile on a nice, beautiful August day. And all the field force would go home to the old apiary site, and the next day those bees only had 50% the colonies only had 50% as many bees in them, and the 50% that was left had never been out of the colony, so they were all the young nurse bees, the bees that are not trying to sting you, the bees that will accept a queen more readily. And because of the lower amount of bees, he could find the queen easier. He was not getting stung up. It was not robbing. It was a good situation, and that's what he did. And of course, you would think initially that, wait a minute, he's trying to build strong colonies for winter and he just lost half his bees. But he found invariably, if he could get a brand new queen in those colonies, that those colonies would go into winter better than the ones that didn't get requeened, because the new queens just did that much good work for him. He lost the field force. So, well, let's talk about field force for just one more moment. So how would that work for us? If you make up nucleus colonies and leave them in the same yard you produce them in, the field force will go home. The bees left in the nucleus will be all young bees, and they will accept a queen much more readily than if you took a nuke, screened it up, and moved it 2 miles away or something, which is what the books tell you to do. I'm killing this plant. That's why I'm wiggling so much. And so, of course, that can be problematic, especially in a place like Scotland where you can have cool weather long into the spring. So what you would do is shake in extra young bees off of open frames of brood, because that's where the majority of the young bees are. And maybe 2 or 3 frames of those young bees, knowing that 50% of the bees are going home. But once again, all the bees that stay there are all the young bees that don't know their way home. and queen acceptance can be much better. I like doing that over a double screen board. You would probably call it a Snell Grove board here. And if you do that, even if you lose 50% of your bees, the heat rising from the colony below will allow the nuke above to take care of the brood with 50% of the bees that it would have otherwise needed. I love using double screen boards or Snell Grove boards. And then not only that, after they get over the shock of losing their field force bees, 7 to 10 days later they can expand much more rapidly because they have all this warmth coming up, and the queen is able to fill more frames with eggs than she would have if she was in a box that didn't have that extra heat coming up. Pushing cage, I don't always use them, but if you want a near guarantee of queen acceptance, this works. I don't know how it turns out in centimeters. In inches, it's 1/8 of an inch hardware cloth. It's just a small hardware cloth, galvanized wire, and it's 1 inch deep. And the reason for that is you want to push it all the way to the midrib, but you still have that depth left for the bees to be under the roof of the cage. We put that cage over a section of comb that has hopefully some hatching cells and some open cells and no other bees. We release the queen in that cage, shut that little door that I cut out there, and push it down. And as the bees hatch, they automatically 100% of the time accept her as their queen. How could they do otherwise? They don't have a choice. And so they will tend to her. She will start laying eggs in these open cells. They will tend to the cells and the larvae, leave her there for 7 to 10 days. Her pheromones are now being spread throughout the colony because she's a laying queen. And you do this carefully, acceptance can be nearly 100%. When I have a $1,000 breeder queen that I don't want to mess around with, that's what I do right there. Finding the blasted queen. Yeah, it's tricky, especially if you're a new beekeeper. You know, older experienced beekeepers can do it almost magically when a newer beekeeper sitting beside them and say, how'd you spot her so easy? There's a couple little minor tricks that I'm going to talk about, nothing big. When I work a single story colony or any box, what I've done here is the frame that's closest to me, I look at very closely. If I'm really worried that the queen possibly could be on there, I might put it in a nuke box and set it aside in case I got to go back and look at it again. Then I will take a hive tool and pry all the frames over close to me, and I effectively create a hole the width of a frame on the other side of the box, and I begin taking the frames out farthest from me one at a time. Why is this better? Because every time I pick up a frame, I'm looking at the dark side of the comb. For instance, if I pick up that frame and the queen's not on it, if the queen's on the next side, on the daylight or the light side of the comb, by the time I'm done looking, there's a good chance she's gone around to the other side. And if you look at the dark side of the comb at first, what it will do is increase your time for finding a queen by 1/3. At least that's my experience. It's just a little trick I use. And yeah, it's not guaranteed. There's no silver bullet here. There's just little things that can help you. If you have a large colony and you absolutely need to find the queen in that colony, put queen excluders between all the boxes. Come back in 4 days, and because eggs hatch after 3 days, whatever box has got eggs in it is where your queen is. At least you know which box she's in. Now, the rest of this is another 10 or 15 minutes, so now's your chance to tell me you think you've had enough and we can move on. This is about how we produce queen cells.
I'm asking everybody else.
Go for it.
Go for it? Okay, all right. I don't have a clock here. Oh, okay, he wants to hear it then, okay. Well, there's no rocket science here, it's just the method we use. Those are good looking cells, I think anybody would agree. It's making queen cells, there's a little bit of an art to it. And many beekeepers are intimidated in the beginning and do not want to do it. But my message is just do it, make your mistakes, and after a few times you'll somehow magically start to get better and better at it. And when you get good at this, not only do you save money, but you can use the genetics that you want to use, and it is so satisfying to create your own queen cells, put it in a mating nuke or something like that, and have a brand new virgin queen mate and take over the colony. I just love it. I prefer making bees to making honey, I really do. So of course choose your genetics. That's a nice Caucasian queen. We have a lot of Caucasian genetics in our outfit. And it's good if you can, there's several mechanisms for isolating the frame that you're going to be grafting off of. This is a box with grooves in the walls where we can slide down 2 pieces of plastic queen excluder that have been cut perfectly to fit that situation. We put a nicely polished, darker comb, not ancient, but darker combs that have color, and the bottoms have begun to be rounded out. We'll drop the queen on that, and when we come back 4.5 days later, we know that all the larvae on that frame are the right age, and we also don't have to go through the whole colony to find the frame that we want for the right age larva. Saves a lot of time. You can buy cages now that are made of queen excluder that you can slip in the box and then put a frame inside it, and we're using those also. Brother Adam again, we find the best results are secured regarding the cell building when the bees feel crowded. Brother Adam, Beekeeping at Buckfast Abbey. I read it in his book, and the next time I heard it decades ago was from a lady by the name of Sue Kobe, which is a famous queen producer in our country. She was the founder of the New World Carniolan line. If you've ever heard of that, you might have read it in bee journals or something. She said the same thing. If all the bees can fit in the box, there's not enough bees. We take a double deep, very strong double deep brood nest colony, and we're going to make it into a combination cell starter and single with the queen above, and come back in a day or 2 later, reverse it, and now create a queen right cell finisher. For newer beekeepers, it doesn't make sense, but trust me, it works pretty good. So that's what a cell builder looks like. That's what it should look like on the inside. It needs to be jammed full of bees for the very best results. Weak colonies do not make great cells. What we're looking at on the left side, we call them division board feeders, in colony feeder, 1.5 gallon American, maybe 1.25 gallon feeder, the type that you use. The next frame would be a frame that was full of fresh pollen. And then the second frame from the feeder, if you can tell, is very narrow. And that's the frame that had the grafted cells on it that we put in the colony. We put it right between the pollen, and then every other frame in there has nothing on it that they can rear a queen from. It can be sealed brood, it can be honey, it can be pollen, it can be foundation, but it's nothing that they can rear a queen on. They are forced to use only the cells that we gave them. Now what we did, this box was set up yesterday, the day before, and we fed it. It was queenless, no brood. We come back the next day and drop in that frame of grafted cells in there, and they immediately jump on it and start drawing these cells out. If you've done it properly, they draw the cells out and make very nice cells for you. And again, we're feeding thin sucrose syrup, very stimulating. So here you're seeing a double screen board with the queenless unit on the bottom. We put the entrance towards the rear. The top box now has the majority of the brood that used to be in this colony. And we shook off half the bees off of that brood into the bottom. She only needs half as many bees in the top to take care of the brood because she has the heat coming from below. Even the field force will go back to the original entrance because that upper entrance is to the back. It's only going to be that way for a day or 2, and we will have something that looks like this. The top has the queen, the bottom has the grafted cells. In other words, the bottom is now a queenless cell starter. And we will come back in 1 to 2 days, and we will actually reverse the boxes. We will put the queen back on the bottom board. We will put a queen excluder in the middle. We will put the cell starter on top. Now the queenless cell starter is now sitting over an excluder on top of a queen right colony. And this is the part that's kind of interesting. They will finish those cells out, and they will do a brilliant job of it. This very strong double deep colony will finish cells, and at first you'd think, well, wait a minute now. They've got, if it was a perfect take, we've got 45 queen cells sitting in an upper box. Are they not going to want to swarm? And 99% of the time the answer is no, they do not, which is a little bit of a curiosity to me. It's like you've kind of thrown them into kind of they're out of sync. And perhaps it's because you use the emergency queen cell mechanism rather than the swarm cell mechanism. And we actually harvest the queen cells 2 or 3 days before they're ripe enough to hatch. We put them in an incubator and get them out of there so that no mischief can occur. And it works really, really good. And that's how we use queen cells. And that's the result right there. Tommy, who used to work for me, was very proud that day. He wanted me to take his picture, and I was glad to oblige him. Every colony in this yard was a cell building colony, and they go on cycles. Like 1 week we'd use this group, the next week we'd use the next group, and the next week we'd use the next group. And because these colonies, when you harvest the cells and take the queen excluder out, are now much like they were the day you started, a strong double deep colony, 3 weeks later you can do it again. And you can use the same colony over and over and over and over. So even if you have only 5 colonies, if you're willing to take one of your colonies and sacrifice it for a little while, you can make queen cells just like this. At that time, this picture was probably 10 or 12 years ago, we were producing 600 to 900 cells every week with this group of 72 colonies. And we were selling cells and also using a lot of them ourselves in all of these nukes we were producing. And we were almost done. Final word, good queens equals greater success. If you can keep very good, young, vigorous queens in your colonies, everything goes up. Winter success, honey production, your averages all go up. You might still have some very good colonies that make a lot of honey with a 2 or even a 3-year-old queen, but I tend to look at my apiary as an entire apiary average, not, in fact, it's kind of funny to me. In our area, sometimes people will say, well, what's your average? How much honey do you average? And many people are tempted to, in their mind, think about their very best colonies and say, oh, I made 100 pounds last year. I try to look at the apiary average. And if I've got young queens that are not trying to swarm and that have overwintered well and all this list of things, my whole apiary average goes up, even though I still may have some colonies that are not doing great. I look at it as the big picture, not the single colony picture. And if I can keep young queens in all my colonies, everything goes up. This is our website, BlueRidgeHoneyCompany.com, Facebook page, Blue Ridge Honey Company. And for anybody that doesn't know, I do have a YouTube channel. And just go to YouTube and type in my name and it comes right up. Some of the videos are very good, and some of them are maybe not so great. So that's it. That's the end of my presentation. I want to say thank you in a very big way. I cannot tell you how special this trip has been to Suzette, my wife, and I. And Michelle, she helped make this happen. We are so thankful to be here. It feels special to be with you folks. We've got another one in Edinburgh tomorrow night, and I'm so looking forward to that too. And I just want to thank you a lot, and thank you for being such nice people.